Here's problem 10.23. The rigid body shown rotates by an axis through its center of mass and perpendicular to the paper. If m is equal to 2 kilograms and L is 80 centimeters, what is the kinetic energy of this object when its angular speed about this axis is equal to 5 radians per second? Neglect the mass of the connecting rod and treat the masses as particles. So we want to find the moment of inertia of this object about its center of mass. So we need to find the center of mass and then the moment of inertia in that order. So let's treat this as if we were on a coordinate system. Let's put the mass m at the origin, and 3m is somewhere at a distance L on the x-axis. So location is at L, and the origin is at 0. And let's find the center of mass on the x-axis. Well, the x-center of mass will be the summation of every mass multiplied by its x position over the summation of all the mass. And in this case, that is going to be mass m times 0 plus 3m times x location of L over the total mass, which would be m plus 3m. So that's going to be equal to 3ml over 4m. m's cancel out, and this will give us a center mass of 3/4 L. So at 3/4 L, right here, we will have a center of mass, and that's our axis of rotation. Hence, our mass m is going to be 3/4 of an L away from that axis, and our mass 3m is going to be 1/4 of an L away from that axis as it rotates around that axis. So our moment of inertia, which is the summation of every mass multiplied by its distance away from the axis squared, is going to be equal to m1 r1 squared plus m2 r2 squared. So that's going to be equal to m times 3/4 L squared plus 3m times 1/4 L squared. So this is going to be 9/16 ml squared plus 3 times 1/16 or 3/16 ml squared, which will give us 12/16 ml squared or 3/4 ml squared. That's our moment of inertia. We can actually calculate what this is in terms of a value. That is going to be 3/4 times m, which is 2 kilograms, and L, which is 0.8 meters squared. So what is that? .96, 0.96 kilogram meter squared. Okay, so that's our moment of inertia about the center of mass. Kinetic energy is 1/2 the moment of inertia times the angular velocity squared. So in this case, that would be 1/2, if I can get this to write for me, times the moment of inertia, 0.96, and the angular velocity was given as 5 radians per second squared. So that will be what? 12. So that's equal to 12 joules of kinetic energy rotationally. So the kinetic energy of this object about its center of mass, treating the rod as being massless, so we're only treating this as point particles, has a kinetic energy of 12 joules. Answer.